In previous lecture, we identified the set of inputs required as part of developing a schedule. In this lecture, we will focus on identifying the set of tools and techniques that could be used for this process. So let's discuss them briefly. First off, we have the schedule network analysis. Schedule network analysis is the overarching technique used to generate the project schedule model. It employs several other techniques such as critical path method, resource optimization techniques, and modeling techniques. Additional analysis includes assessing the need to aggregate schedule reserves to reduce the probability of a schedule step when multiple paths converge at a single point in time or when multiple paths um, diverge from a single point in time to reduce the probability of a schedule slip. Reviewing the network to see if the critical path has high risk activities or long lead items that would necessitate use of schedule reserves or the implementation of risk responses to reduce the risk on the critical path. Schedule network analysis is an iterative process that is employed until a viable schedule model is developed. Then we have the critical path method. The critical path method CPM plays a significant role in developing a schedule process in project management. It provides a systematic and analytical approach to effectively plan and schedule activities, ensuring the project progresses smoothly and stays on track. The relevance of CPM in developing a schedule process can be ascertained by the fact that it helps in identifying critical activities, estimating project duration, allocating resources, managing dependencies, schedule compression, risk management, communication, and collaboration. Then we have the resource optimization. Resource optimization is used to adjust the start and finish dates of activities to adjust planned resource use to be equal to or less than resource availability. Examples of resource optimization techniques can be used to adjust the schedule model due to demand and supply of resources include resource leveling and resource smoothing. Then we have the data analysis. Data analysis is the process of inspecting, cleaning, transforming, and modeling data to extract useful information, draw conclusions, and support decision making. In project management, data analysis plays a crucial role in understanding project performance, identifying trends, predicting outcomes, and optimizing project processes. What if scenario uh, what if scenarios in data analysis involve creating hypothetical situations by altering variables or assumptions to understand the potential impact on project outcomes. Project managers can explore different scenarios to assess the feasibility of alternative approaches, evaluate risks, and make informed decisions. By analyzing what if scenarios, managers can identify potential risks, evaluate mitigation strategies, and optimize project plans. Then we have the leads and lags. Leads and lags are refinements applied during network analysis to develop a viable schedule by adjusting the start time of the successor activities. Leads are usually in limited circumstances um, to advance a successor activity with respect to the predecessor activity. And lags, they are used in limited circumstances as well, where processes require a set of period of time to elapse between the predecessors and successors without work or resource impact. Then we have the schedule compression. Schedule compression refers to a project management technique used to shorten the project duration without sacrificing the quality of deliverables. It involves analyzing the critical path, identifying non-critical activities, and finding ways to expedite their completion. Crashing and fast tracking are its two key components. Both crashing and fast tracking are used when there is a need to expedite project completion. However, it is important to assess the potential risks, additional costs, and impacts on the overall project before implementing these techniques. Project managers must carefully evaluate the trade-offs and consider the feasibility of resource availability, dependencies, and quality implications when deciding to crash or fast-track activities in the schedule. Then we have the project management information system. Project management information systems include scheduling software that expedites the process of building a schedule model by generating start and finish dates based on the inputs of activities, network diagrams, resources, and activity durations. Then we have the Agile release planning. Agile release planning provides a high-level summary timeline of the release schedule, typically 3 to 6 months, based on the product roadmap and the product vision for the product's evolution. Agile release planning also determines the number of iterations or sprints in the release and allows the product owner and team to decide how much, how much needs to be developed and how long it will take to have a releasable product based on business goals, dependencies, and impediments. Since features represent value to the customer, the timeline provides a more easily understood project schedule as it defines which feature will be available at the end of each iteration, which is exactly the depth of information the customer is looking for. See you in the next lecture.